Welcome back to Quantum Weirdness. Today, we're asking a fundamental question. Why don't you fall through the floor? It seems obvious, right? The floor is solid. But if we look closer, physics tells us a different story. Your atoms never actually touch the floor's atoms. Atoms are 99.9% empty space. To visualize this, imagine an atom with the size of a stadium. The nucleus would be a marble on the 50-yard line, while the electrons are like tiny gnats in the top rows. So why don't the empty atoms in your feet just slide right through the empty atoms in the floor? The answer lies in a strange quantum property called spin. But it's not like a spinning top. It's an intrinsic angular momentum. Think of it as a permanent label every electron carries. In 1925, Wolfgang Pauli realized that this label creates a very strict rule for the universe. The Pauli Exclusion Principle states that no two electrons can occupy the same quantum state simultaneously. They are like antisocial roommates. Only two can share a room, and only if they have opposite spins. Particles like electrons are called fermions. They are the matter particles that refuse to overlap. Contrast them with bosons, like photons, which love to pile up in the same state. That's how lasers work. But for matter, the rule is strict: stay apart. Because they can't overlap, electrons are forced into higher and higher energy shells. Because electrons are forced into higher shells, they stack like floors in a skyscraper. This stacking creates the volume of an atom, the reason matter takes up space. When you stand on the floor, the electrons in your shoes in the floor are being squeezed together. They push back with electron degeneracy pressure. It's not a physical touch, but a quantum demand. That solid feeling is actually billions of electrons following Pauli's rule. They push back with an invisible quantum demand that keeps you from falling through the floor. This principle is so strong, it can even hold up the weight of entire dead stars against gravity. In objects like white dwarfs and neutron stars, it's this degeneracy pressure that stops them from collapsing into a singularity. It's the ultimate cosmic shield. Without it, stars would collapse, and you would simply melt through your chair. The math behind it is called an antisymmetric wave function. It's the universe's way of keeping things orderly. If you were to swap two identical electrons, the sign of their total wave function flips. This simple symmetry requirement is why the universe doesn't just collapse into a point. Remember, it's not the electrostatic repulsion of charges doing most of the work. It's the exclusion principle. Intrinsic spin plus the Pauli rule equals a world that we can actually stand on. So, next time you take a step, thank the antisocial electrons for holding you up. For more quantum weirdness without the math, subscribe to James's Physics 101 and check out our full playlist. Stay curious.